In this video, I'm going to be taking a kind of a bigger leap into geometry and talking about the congruency postulates. So, congruent means that it's the same size and the same shape. So, if I got a triangle and I got another triangle, if they're the same size, if side X, Y, and Z and A, B, and C are equal and it's the same shape, then they are congruent. And let's say a square and a triangle are not congruent, they're not the same shape, or a triangle that's bigger with, let's say, x plus 2, y plus 2, z plus 2, they're not the same size, so they're not congruent. They must be the same size and same shape. Okay? And a postulate is just an assumption made assumption made in geometry that can be used to solve problems or just, make a point in geometry. Okay. So, we've made assumptions before with the alternate interior angles where you translate, let's say, these two lines are parallel, and we said that this right here is equal to this angle. You have to assume that, but I encourage you to actually get a protractor and measure that and actually prove that they're equal or congruent. They're the same size and shape. And let's begin. They got the angle side congruency postulate, angle side angle congruency postulate, side congruency postulate, side angle side congruency postulate, and a right side right angle hypotenuse and a side congruency postulate. So, as I've said in the previous videos, right now you should just memorize these postulates and use them to solve problems in the future. I'm going to give some problems where we're going to solve them and work through them using the congruency postulates. And in this video, I'm going to prove to you as much as possible that these congruency postulates are true. Now, there is no proof for them other than using a protractor and a ruler to prove that they're real. There's no actual proof, but I'm going to do my best since you're a beginner, and you should go through these steps as a beginner to try and figure out, hey, can I prove this? So we're going to try it, and we're going to do our best. We're just going to pretty much use intuition, but there's no proof other than protractor and ruler. And after that, just memorize these postulates, and every once in a while you can go to the proofs again that I'm going to try and make up right here in this video. But just for the most part, just memorize them so you can solve problems. And let's begin. So the angle side postulate. Let's say you have a triangle and you have another triangle where the angle and the side is equal to the angle and the side of this triangle. Then the angle side congruency postulate tells you that these two triangles are congruent. They're the same size and they're the same shape. But let's try to prove it wrong so we can prove it right. So, let's say, and I encourage you to get a protractor and a ruler and put some actual numbers in here with some real triangles and actually prove that this is true. I definitely encourage you to do that. In fact, if I was teaching this in the classroom, that's what I would get my students to do. So anyway, let's erase this triangle, and let's say this angle and this angle are equal, then this side must be equal, because this angle opens up the same as this one, and this side length, let's see, this angle opens up the same as this one. Like I said, there's no proof for this, so I'm trying my best at trying to prove it, and there's no other way you can do this. I mean, this angle right here it's in a way such that this side length is equal to this side length. And that's that. So, protractors and rulers definitely prove these postulates. There's no other way you can try and, like, if you was to try and say that this length wasn't equal to this length, then this angle and this angle and this angle and this angle could not be equal. And let's say, now let's move on to this postulate, the angle side angle. Let's say you have a triangle, you have two triangles, you have an angle, a side, and an angle. And let's say this angle, this side, and this angle is like that, and they're equal. And they have to be in that order. They have to be right next to each other. This angle must be next to this side, and this angle must be next to this side. It can't be like this. This is not angle, side, angle. The angles and the sides must be next to each other. So, this angle, if this side wasn't equal to this side, then let's say this angle opened up more. Let's say this side is equal to this side. This angle opened up more. Then they wouldn't be congruent. But you bring it in as much as possible and you see that they're congruent. Now let's move on to the side postulate. Let's say you have a triangle and a triangle. And this side, let's say all these three sides are congruent. Then these two triangles are congruent every time. Get a protractor, or get a ruler to prove it. Same thing for side angle side. Let's say you have two triangles. You have a side, an angle, and a side. Side, angle, and a side. These two triangles are congruent. Now, there's one more postulate. The SSA, or you can write it backwards, but I'm not going to do that. It's the same thing as writing it backwards. All of these are the same thing, forwards and backwards. All of these are the same, forwards and backwards. So the SSA is like this. Let's say there's a triangle. Actually, let me draw it better than this. Let's say there's a triangle like this. And let me draw this like this. And there's a triangle like this. And the side, let's say side, angle Let's see. I'm trying to remember how this is done. Side angle. Yeah, side angle. Let's say there's a side, and an angle, a side, and an angle. They're congruent. But are they always congruent triangles? No. There's an ambiguous case. This can be open like this, or it can be closed like this. So it can be side angle, and they're the same side angle, but they're not congruent. But get this. If the triangle, let's say you have two triangles, and you have side angle, and this is a right triangle, and this is a right triangle, and you have side angle. If it's a side angle postulate, and if it's a right triangle, and the hypotenuse is equal, and the sides are equal, one side is equal, then they are congruent. And that's the right or HS postulate, right hypotenuse side postulate. And that's all of the postulates. I didn't go through too much trying to prove it. You can try and figure that out on yourself. I mean, it's hard to try and prove these myself, other than using a protractor and a ruler. But you should memorize these things. And I'm going to give some problems for you to try and solve with all of the problems, or all the things I taught you so far. We can try and solve the problems with the tools in the toolkit that I gave you. And in the future, I'm going to be talking about similarity postulates. Those are taking another leap. Just like this was taking a leap in geometry, that's another leap. And you can use similarity postulates to solve many problems. And let's move on.